Hello, cosmic explorers, and welcome back to our channel. Today, we're venturing out to the far reaches of our solar system, to a world of brilliant blue and raging storms. We're talking about Neptune, the eighth and most distant planet from the Sun. It is a place so far away that it remains one of the greatest enigmas in our celestial neighborhood. Why, after all these years, does Neptune remain such a profound puzzle? Let's find out. Our first real introduction to Neptune was in 1989, when NASA's Voyager 2 spacecraft flew by. For the first time, we saw this gas giant not as a faint dot, but as a vibrant, dynamic world. Voyager 2 revealed a stunning azure sphere, streaked with wispy white clouds of frozen methane and punctuated by colossal storms, most notably the Great Dark Spot, a tempest so large it could have swallowed the entire Earth. It was a breathtaking yet fleeting glimpse. This single flyby gave us a treasure trove of data, but it was just a snapshot in time. It raised more questions than it answered, setting the stage for decades of cosmic curiosity. Think about it. Our entire library of close-up images comes from one brief encounter over 30 years ago. One of Neptune's biggest mysteries is its surprising internal heat. Being so far from the Sun, you'd expect Neptune to be an incredibly cold, inert ball of gas. But it's not. In fact, Neptune radiates more than twice the energy it receives from the Sun. Where is all this extra heat coming from? Scientists have a few theories. One idea is that it's leftover heat from the planet, S formation billions of years ago, slowly seeping out from its core. Another intriguing possibility is that deep within its atmosphere, under immense pressure, methane could be breaking down and forming diamonds. As these diamonds rain down through the planet's dense, fluid layers, they could generate heat through friction. Diamond rain on Neptune. It sounds like science fiction, but it's a leading hypothesis to explain this thermal anomaly. This internal furnace is what likely drives Neptune's extreme weather, including the fastest winds in the solar system, which can reach speeds of over 200 miles per hour. It's a planetary weather engine we are only just beginning to comprehend. Speaking of weather, let's talk about those storms. The Great Dark Spot, which Voyager 2 photographed, was a massive anticyclonic storm system. But when the Hubble Space Telescope turned its eye toward Neptune a few years later, in 1994, the spot was gone. It had vanished completely. Since then, Hubble has spotted other dark spots appearing and disappearing on the planet, each lasting for a few years before fading away. This is completely different from Jupiter's Great Red Spot, which has been raging for centuries. Why are Neptune's storms so transient? What causes them to form? And where do they go when they dissipate? Are they sinking deeper into the atmosphere, or are they simply breaking apart? Without a dedicated orbiter to watch these storms evolve in real time, we are left to piece together the puzzle from blurry, long-distance observations. It's like trying to understand a hurricane by looking at a single photo taken from space. And then there's the magnetic field. Neptune's magnetic field is, to put it mildly, bizarre. Unlike Earth's, which is roughly aligned with its rotational axis, meaning our magnetic North Pole is close to our geographic North Pole, Neptune's is tilted by a staggering 47 degrees. Imagine if your compass needle pointed toward Florida instead of the Arctic. Not only is it tilted, but it's also significantly offset from the planet's physical center. What could cause such a wonky magnetic field? The answer probably lies deep inside the planet. On Earth, our magnetic field is generated in our molten iron core. But for gas giants like Neptune and its neighbor Uranus, which has a similarly strange field, it's thought to be generated in a shallower layer, a super-pressurized, electrically conductive ocean of water, ammonia, and methane ices. The complex churning motions within this icy fluid shell could be responsible for creating such a chaotic and off-kilter magnetic field. This unique structure creates a complex and dynamic magnetosphere, the region of space controlled by the planet's magnetism, which is constantly shifting as the planet rotates. Let's not forget Neptune's family of moons. The largest, Triton, is a mystery all on its own. It's the only large moon in our solar system that orbits its planet in the opposite direction of the planet's rotation, a retrograde orbit. This is a huge clue that Triton wasn't born alongside Neptune. Instead, it was likely a dwarf planet, similar to Pluto, that wandered too close and was captured by Neptune's gravity long ago. Triton is also one of the coldest objects in the solar system, yet it's geologically active. Voyager 2 saw giant plumes of icy material, possibly nitrogen frost, erupting from its surface. These cryovolcanoes suggest that despite the frigid temperatures, there's some kind of internal heat source. But what? Tidal forces from Neptune's pull could be warming its interior, creating a subsurface ocean. A hidden ocean on Triton? That would make it one of the most compelling places to search for extraterrestrial life in our solar system. We need to go back to find out. So why, after all this time, do these mysteries persist? The answer is simple: distance. Neptune is about 30 times farther from the Sun than Earth is. That's nearly 3 billion miles away. It's an incredibly difficult and expensive journey that takes over a decade. Voyager 2's flyby was a triumph of engineering, but it was just that, a flyby. To truly solve these puzzles, we need to do what we did for Jupiter with Galileo and Juno, and for Saturn with Cassini. We need to send a dedicated orbiter and atmospheric probe to Neptune. A mission like this would circle the planet for years, mapping its gravitational and magnetic fields in high detail, studying its atmospheric composition, and monitoring its ever-changing weather. It could also perform close flybys of Triton, confirming whether a subsurface ocean exists. Scientists have proposed missions like the Neptune Odyssey, but they are still in the concept phase, competing for funding against other compelling scientific goals. Neptune represents the frontier of planetary science within our own solar system. It's a cold case in the truest sense of the word. It guards its secrets fiercely, hidden by distance and a veil of deep blue clouds. Every faint image from Hubble, every piece of data reanalyzed from Voyager 2 only deepens the intrigue. It reminds us that even in our own cosmic backyard, there are still new worlds to explore and profound mysteries waiting to be solved. Answering the questions about Neptune won't just tell us about this one distant planet. It will help us understand the formation and evolution of planetary systems everywhere, including our own. The story of Neptune is far from over. In fact, it's just beginning, and the next chapter is waiting to be written by a future generation of explorers. Thank you so much for joining me on this journey to the edge of our solar system. What do you think is Neptune's most fascinating mystery? Let me know in the comments below. If you enjoyed this cosmic adventure, don't forget to hit that like button, subscribe to the channel, and ring the bell so you never miss another exploration. Until next time, stay curious.